So welcome again. Tonight we have one of our members that is a guest presenter. Helen was recently down in Colombia and did a presentation on SOFIA and infrared observing, as well as took a lot of pictures of the very large I'm jealous audience that she had down there. So we'll let her do a presentation on that, and then you can ask questions afterwards. But first, as usual, we'll go through the news. So NASA confirmed as of yesterday evening that the James Webb Space Telescope is currently scheduled to launch no earlier than December 24th. They won't guarantee it's going to be on the 24th because they're hedging their bets. Something could go wrong. The weather could be bad. They seem to have resolved their data communications issue between the spacecraft and the launch vehicle, whatever that was. So it's going to go up on the 24th, we all hope. A nice Christmas Eve present. So the Ingenuity helicopter on Mars flew again. 17th flight. It's funny, they don't, in the video, they don't tell you the flight number anymore, but I know this is flight number like 12 or 13, because the background scenery is different. And in fact, the helicopter has gone back to where the spacecraft originally landed, and it's waiting on the rover to catch up with it, because it can fly faster than the rover can rove. Now, since it's the first helicopter on Mars, every time it does something, it's the first ever, it's the longest ever, it's the greatest ever. So NASA proclaimed a couple of things. It's the 17th flight. Nothing has ever flown before, so 17 is a record. It flew more than 30 minutes, 117 seconds, if you add up all of its flights. So that's the longest flying aircraft on Mars. Had a couple of other things here too. Let's see. The longest distance by a helicopter on Mars, 2.2 miles. The highest flight ever on Mars, 40 feet, and the fastest flight time, 10 miles per hour, which compared to things we have on Earth, just regular quadcopters, it's very anemic. But seeing as how it's designed to be very, very lightweight, it can't fly for all that long or all that fast before it runs out of battery juice, because the air pressure on Mars is so slight that the props, which are actually counter-rotating, so it doesn't need a tail rotor, and it only needs one motor with a reversing gear. So that's why you just see the central dual props, and that's how it flies. The legs on it are very large and springy. They're made out of carbon fiber. That way, if it doesn't land quite square onto the surface, it kind of bobbles a bit and then rights itself. And the little panel on top, that's the solar panel that charges the battery. So that limits its flight time, its battery charging duration and size. And, But anyway, it set a bunch of new records because there have been no previous records. The Sherlock instrument aboard Perseverance has detected and confirmed the presence of organic molecules in dirt and rock in the Jezero crater of Mars.
That's confirmed.
It's confirmed. Now, what is an organic molecule? Stuff that contains carbon, but that can be natural or it can be through biologic means. So it's a precursor, but it is not confirmation of life on Mars or even previous life on Mars. However,
normally they look for long chain hydrocarbons, not just hydrogen and carbon, like a little bit bigger.
But they're saying, yes, we've once again found detections of organic materials on Mars. This is not the first time, nor is it the first craft to have done this. But they're now saying that, yes, we're going to take this material that we've captured and we're going to put it in one of the recovery tubes. And the next time we go back to Mars and we pick these tubes up and bring them back to Earth, we can do something that we can't do here. Run them under an electron microscope and see if we find any biologic fossils, which that may be the source of the organic material, but who knows until they see it. So put a giant push pin in it and wait about 10 plus years before they go back and pick them up and then bring them back to Earth and analyze them. And even more on Mars, this one was something that was detected from orbit. People have likely heard of the Valley Marineris crater system, canyon system on Mars, and it is the largest canyon system, any canyon system we know of, any planet in our solar system. It's about 10 times.
Valles Marineris is zesty and powerful.
The amount of water that they found is not trace amounts, not small amounts. They're identifying it as considerable, as in lots of water. Now, how do they know it's water? Because of the amount of hydrogen in it. They haven't detected water. They've detected molecular hydrogen using spectroscopic imaging of the floor of the crater, of the canyon. So they've detected what would be hydrogen in molecular composition, which is usually H2O, water. So I was thinking, if there is really that much water down there, and they're saying that it's been deposited in layers of silt, of dirt covering it, then it's kind of like water in sediment. And if it's really cold down there, it's like a permafrost. So if there's really that much water down there and it's there for the taking, so to speak, then if we're going to put a permanent habitat on Mars, probably put it down in the canyon floor. That would be good, because then you have access to water, and water you can use for drinking, making air to breathe, making rocket fuel, all those sorts of good things that water is good for.
You could start a spa.
Yes, you can heat it up and make steam for your spa. Yeah. But I was thinking further on it and thought those lava tubes they're always talking about. If a lava tube that's extinct were to end at the floor of the canyon, then they would have shelter from radiation and from micrometeoroids, as well as a source of water. And if it's really buried in silt, that would protect the water from evaporation. The air pressure would be a little higher in the canyon floor because it's several thousand feet down. So maybe the water would be not frozen solid, but maybe slushy, cold and slushy. So this is another thing to put a push pin in, and let's see if any of the space craft that they create on Earth decides, I'm going to go land at the bottom of the canyon, and then I'm going to stick out my probe and measure water in the ground, because they may find slushy water. And if it's salty, slushy water, that's ocean-like. If the canyon floor was the last place that Mars had water, then you can expect, if there was life on Mars millions of years ago, that remaining water would be very salty. Now we're going to switch from Mars to Jupiter. So NASA has this very inexpensive solar-powered spacecraft that they sent to Jupiter called Juno. And it's been orbiting around Jupiter and its moons now for a couple of years. And it did a flyby of Ganymede. Now, don't get all excited. This is not a picture of anything on Ganymede. This is some of the Jupiter cloud tops, but it shows what the Juno cam can do. Makes very pretty pictures. Look at the detail resolution. That's only a 2 megapixel camera, but it's a full color camera. So it makes very pretty pictures. It originally didn't have one, but NASA came to their senses and says, we can't just measure data. Nobody wants to see data. They want to see pretty pictures. So they decided to put an educational purpose camera. And now they've been using the camera for science. But that's not what this article is about. This article is about another instrument on board Juno called WAVES, W-A-V-E-S. I don't know what the acronym stands for, but it's meant to measure the magnetosphere as electromagnetic radiation. You can think of it kind of like a spectrograph for radio waves. and it measures from a certain mid-range all the way up into very high frequencies. So it can actually measure sources of plasma. They turned it on when they did their flyby of Ganymede to see if Ganymede had an electromagnetic field, a magnetic field, which, you know, we have one for the Earth, and that's where we get our auroras. So they turned on waves, and as they flew past Ganymede, they recorded data. You can't let data just sit there as data, because people don't get data. They get stuff that is physiologically perceived. And so they did a shift, and they took the radio frequency spectrum and shifted it way down until it became audio frequency. And when it became audio frequency, now people can hear it. So if you follow the link, there's 50 seconds of whistly sounding audio. So if you notice, as the spacecraft got closer to Ganymede, the amplitude went up. The frequency didn't change that much, but the amplitude went up. And then it got to a certain point, and that was closest approach, and then it started to trail off. But it's just one of those things that, well, you've got to prove that Juno is still in the news. So that, notice how they put quotes around here's, because it's not audio. They had to shift it to make it audio. It's kind of like when amateur astronomers take pictures in hydrogen alpha, which the human eye can't really see all that well, and then they color them different colors, so you can see the different levels of intensity. Same kind of thing. And we have another probe around a different part of the solar system. This is the NASA Parker Solar Probe. The media likes the fact that it touched the sun. Trust me, if it touched the sun, we wouldn't hear from it anymore. But it's on very long elliptical orbits so that it can dive closer and closer to the sun. Now, what's closer? Closer is not all that close. The closest approach at the moment is 10.46 million kilometers, or 6.5 million miles. So that's as close as it gets to the sun. That's well close. That's well inside the orbit of Mercury.
Yeah.
And the only way it can do that without actually falling into the sun due to the sun's gravity is to have a very elongated orbit, so that by the time it wants to go past the sun, it is moving at a very high rate of speed. So it sort of blasts past the sun, and it's close enough that it can actually have its detectors pick up things. And it actually has carbon composite shields on the sun side, and then it has probes that kind of stick out past the shield to pick up data. An interesting probe. My guess is it's kind of like the helicopter on Mars, in that it's done all of the stuff that it's supposed to do. Now they're just going to make it go farther and farther into the oopsie mode. And at some point we'll go, well, it's run to the end of its course, and now we just dove it into the sun so we get that last minute data. But that's probably a few years away. And then another astronomical solar system object. Let's see if this comes out. There we go. Okay, good. Comet Leonard. Comet Leonard is now on the other side of the sun. It's done its swing around the sun, and now it's headed away from the sun, which means it's going to be coming closer to Earth again. But it's flying into its tail, and so it's going to be a little harder to see. And if you do see it, it will be late in the afternoon, just as the sun disappears over the horizon until it gets dark. And right now it's fairly close to the sun, but over the next 5 or 6 days, it's going to be moving farther away from the sun. So you may find a good night when the weather is clear and it's just far enough away from the sun so you can see it, despite the sun. And right now we have the moon out and it's a fairly bright moon. And, you may find that all the tiles come together and for a brief moment, you'll get to see it. But I do have a picture here. Jason caught a picture of it. So he posted it on the Fox Observatory Facebook page. Come on, we did this earlier. There we go. Okay, can you see it?
Oh, yes.
Very nice. Right next to globular cluster M3. He did this when it was on the other side of the sun. So he took this 3 a.m. before sunrise. So the moon had already set and he got a good shot of it. That's the kind of thing you want to post to a magazine.
However, during contests, you can compete and win money.
Yeah, some of the astronomical equipment manufacturers will have annual contests and, they'll give away a product that they make, which means it didn't cost them that much. But, if you want a free Zero camera or something like that, they'll have a contest. And this would be a contest worthy possibly winning because it's a limited duration item. And has good color contrast on it.
Jason has won previously a contest.
Yes, I think so. Yep.
No, he has. I talked to him and he had told me about winning one, and he was surprised to find it in a magazine that some advertisement had bought his picture. Once you win an award, you lose the rights to the picture.
Yes.
And so he then one day he was looking through a magazine and he saw his picture that had won an award. So that was interesting.
So the NASA Space Launch System, the SLS, ran into a communications glitch. Seems to be a lot of those communication glitches happening lately, and they've delayed the launch again. It was going to go up and not with any people on board, but it was a demonstrator of the Artemis launch vehicle, and it was going to go up and go around the moon and then come back to the Earth, the same way that Apollo 8 did. No people on board, but they had to cancel that, and they're going to move it out to March or April because Boeing has to replace a communications module on some of the systems, the avionics systems. We've got another company launching things. This is the long-standing successful SpaceX. Early this morning, launched a Falcon 9 with 52 of the version 1.5 Starlink satellites. Now, normally it can carry 60, but apparently the version 1.5 are a little heavier. I think it's the lasers they put on them. It makes it each a little heavier. So instead of carrying 60, it carried 52 of them. Not only did they continue to launch Starlink satellites, but they continue to reuse their first stage booster. This is the 11th time that this particular Falcon 9 first stage booster was used, and they plan on using it again. So that's a lot of cost savings to reuse the boosters. The fairings, the sort of upper nose section that encompasses the satellites, I think they said it was the 4th and 5th time that the individual fairing halves were used. So that's how they save a lot of money, is reusing those things. But it's not just that, they launched it from Vandenberg Space Force Station in California, as opposed to Kennedy. And the reason why they launched it in Vandenberg is they wanted the satellites to be in orbit 90 degrees to the existing array of satellites. This is kind of the upper deck of satellites. So the lower deck of satellites communicates with the upper deck via laser, and then that way they can relay from satellite to satellite, layer to layer, to get to a ground station. Complex stuff. And of course, the first stage did land on a drone ship, their favorite. Of course, I Still Love You, out in the Pacific Ocean.
What are they doing with lasers?
They're using lasers for communication between the satellites. Radio disperses too quickly. The lasers, by the time the beam travels through the vacuum of space, it hasn't dispersed a lot. So they can use lasers for gigabit level communication between the satellites. And this evening, not too long from now, they'll launch a different Falcon 9 from Kennedy for a commercial customer satellite launch. It's Turksat 5B. Apparently, it's a commercial satellite for the nation of Turkey. And now we're going to shift from space down to my favorite discussion items on Earth, which is battery-powered electric vehicles. So Nikola, another company making battery-powered vehicles, delivered to the Los Angeles shipyard one and their first electric truck. Now, they didn't actually deliver it to the operations of Los Angeles seaport. They delivered it to a third-party company that uses these trucks for like tugboats around the yard. So when a container comes off of a ship and the crane wants to deposit it on the ground, it can't deposit it way into the sort of parking area for all the containers. It actually puts it on the back of a small chassis truck, and then the truck drives it around to the destination, and then a different crane lifts it off the carrier and stacks them up. So this is a pilot truck for the shipyard. They have 30 more of this particular model of truck that they have to deliver in the next year. So it's not actually high volume.
Are they man operated or autonomous?
They are not autonomous. This is called a Nikola Tre battery vehicle. Nikola is also going to be making hydrogen-powered fuel cell vehicles that are supposed to get up to 500 miles, but they have yet to actually deliver any of those. And this is the first one of these Tre vehicles that they've delivered. Now, I don't think this would have even occurred except for the fact that there are California and federal incentive payments going out to this company that ordered the truck to cover the cost of the truck. So I don't know how much they actually paid for the truck, but it's far less than list price. And speaking of deliveries, GM delivered their first electric Hummer. Now, if you remember the Hummer, it was a big, enormous, gas-guzzling beast of a machine, very wide, very heavy. The electric Hummer is the same width and length because it's underneath the same body chassis, but it's got a lot of batteries in it to haul around that extra heavy weight. A Tesla Cybertruck is going to be very, very much lighter in weight, and therefore it needs fewer batteries to go farther and to accelerate faster. I mean, it sounds like a really great horsepower vehicle if you can afford the $110,295 base price tag for it. So they're not going to be shipping a lot of these. They didn't ship this to a GM employee. They shipped it to somebody who can afford it. But it has 1,000 horsepower. Now, if you think about it, a Tesla Plaid, which is a 4-door passenger sedan, also has 1,000 horsepower, but it's probably a half to a third of the weight of the Hummer. So it can do a lot more with that 1,000 horsepower than the Hummer can. But it's nice to see that GM is finally delivering something that has batteries in it, because they discontinued deliveries of the Volt until they resolve their battery combustion issue with the LG batteries. And that is the news that I had for this week. Did I miss anything?
Yeah, the helicopter.
What about it?
I thought it was getting too heavy from the sediment.
Oh, no. They found out that if you just make the blades spin faster, they're going to make them spin faster and faster and faster up to the limit of the motors. And given that, they were able to fly it again. And yeah, it was getting heavier, but apparently they can spin up the rotors enough to compensate for that. So it's back to, it's a bit burdened, but it's back to flying its normal missions. But I think it's still
the
gonna
thing
quite-
is, the other thing is that it's temperature dependent. So if it's too hot in Mars, that would be very cold here on Earth. There is very low pressure, so the hover, you cannot, you cannot fly because there is not enough air to actually move.
well, I
The
think
pressures are too low.
yes, it's in summertime now, and I think it can actually fly. But if they use the original propeller RPM settings, it would not fly. They wouldn't get sufficient liftoff thrust. But they just kept raising the numbers, and now they can make it fly. And even they're flying despite the fact that the landing feet are covered in orange dust, which adds to the weight of it. So just, it's already done everything that it was supposed to prove. And now it's just, well, if
Time to play.
it needs more RPM, crank it up. And they're going to continue to do that until they find that the dust starts to wear down the probably aluminum magnesium gearings. And then all of a sudden it's going to have a bad day.
Well, mission accomplished already.
Oh, more than mission accomplished. It's got new records, like 5 different records it set. Because
Yes,
it's the first.
it's gonna need a whole chapter on the Guinness Books of Record.
I haven't noticed that they've done that yet. But yeah, does the Guinness Book of Records only apply to things on Earth?
Yeah, I don't know.
They need a new edition, the Mars Guinness Book of Records.
Yes.
It is the Guinness Book of World Records.
Yeah, you can
It's
have the
another
Academy-
world record.
They can start a
Records.
whole new one. People don't have to buy new ones because now you have to buy the Mars edition. There will be no sessions on December 25th. That's Christmas Day. And no session on January 1st. That's New Year's Day. So enjoy your time off, however you wish to spend it. The first session of the new year will be on January 8th, and it will be the business of androids. And we'll talk about, what makes sense to think about when you're creating an android and you're trying to mass market them and get them into as many nooks and crannies in the American workforce as possible, so you can sell a bajillion of them and make $1 bajillion. I think by the time that something comes out to compete with it, Tesla will probably be dominant in that market, because it's my understanding they're taking all of the artificial intelligence capabilities that they've got in the full self drive, and they're going to be using that so that the Android will know how to navigate. So when you put in an order for your Android, you just give Tesla the address of the business it's supposed to report for duty on, and it will walk there or catch a ride. Maybe it'll show up in a Tesla and get out of a Tesla. I don't know. But yeah, it won't. Yeah. Can you imagine it hitching a ride and then somebody trying to steal it?
Uh-oh.
Anyway, the second session of the new year will be access and use of scientific research data. So I was studying a new mission that NASA is going to be thinking about doing in the future. And there are now rules that if you want to do a mission with NASA, you have to come up with your own regulatory response plan for the long-term archiving and public repository access, most of the time for free, of the pretty much raw scientific data. So this will be the data that's been vetted as, it's not a noise burst, it's really data. It does not have to have a peer-reviewed proclamation associated with it. It can just be data. It's good data, whatever the data is, use it for whatever you want. And they'll specify the data and you can go look it up and gather it. When Héllen was aboard SOFIA, even before the 1-year delay, I found the website. They didn't hide it all that more securely, and there was no login for it. Strange. but I was able to get the raw SOFIA data, and it's more than just pictures. It's all sorts of just odd, who needs to know that kind of data that the sensors will record, the missions record, and it's just there for you to look up for analysis. So if 20 years from now, we start thinking about something that we didn't think about previously, and we have to find some examples of it, there'll be petabytes of archival data that you can just go up to the online repository and request, and then peruse to your heart's content and come away with your own conclusions, and then have somebody do a peer review, and you're published. Even if you're not a principal scientist of a mission, you'll have access to the data, which I think is great. And I've already, in an email to Will at Space Telescope Science Institute, said, if you know what the web is doing with their data in the way of public access to it, point me to the document, and I'll include that in this presentation. Because hopefully by then the web will have been launched, and it may not be completely opened, but my guess is it will be already taking various sample data of itself throughout the mission. Like, what temperature am I? How much power do I have? How much energy am I getting out of my photovoltaic cells? All that data gets recorded, and it'll be available in a repository. So that will be good sample data to prove out whether the public can access it or not, even before the pretty pictures arrive, even before they come away with conclusions as to, what an exoplanet's atmosphere contains. And speaking of such things, I got an email from Will, who said, when we start gathering data on exoplanet atmospheres, and we start coming away with conclusions as to the formation of stars and the formation of planetary disks, could I come back and present to your group? Absolutely, yes. So I've stitched him up that when he has something to present, he's going to be presenting this time, and this time he'll create the content and do the presentation. The idea is, after he does the presentation and we record it, I'll do my usual editing and post it up on the YouTube site, and then he can proclaim that as publicly announced peer-reviewed data, which I think we would be the source for that data, which would be great for him because now he's published to the public, and great for us because we're the ones that did it. So
We got a scoop.
yes, we will have a scoop. Now, given that he's about third-tier scientist on the web, so he's not a principal, he's not the organization group, he's like the data gatherer for it.
So the one who actually works.
The one who actually works in the trenches for a living. But remember, nobody gives those people any credit.
Nope.
They don't get to go up for their Nobel Prize. It's the guy 2 tiers above them that wears the fancy suit. So that'll be interesting. And with that, I think we're ready for Héllen to present. Any other comments or questions before we get started?
So for those who are just napping a little bit, I'm going to start my presentation. So I'm going to share. So this is where it starts. So I went to Barranquilla in Colombia. It was awesome city. And we did a presentation because one of my ex-trainees at Fox, it's Lee, he's doing, he was invited to do a presentation, and then he invited me in. One people introduced to the other, so we ended up going, and it was a blast. So this is the actual presentation that I did, and for few events. So I repeated the presentation twice, and I did another event too. And then that's how it starts. ¿A quién le gustan los telescopios? Oops, that's the wrong language. Okay, so let's go here. Let's go here. Okay, well, I guess for this crowd here, this is not a good slide. So let's start with the good one. Okay, who likes telescopes? And then this is the chance for the crowd to go, yeah. Okay, and who likes space? Yeah. And then who likes airplane? Yeah. So you mix everything. So you have telescopes, you have space, and you have airplane, and you get SOFIA, the Stratospheric Observatory for Infrared Astronomy. So this is the actual airplane that has a telescope inside, and it opens when it's flying. So this is a video that I'm going to show to you, and you probably will just see the video, not see the sounds. That's not necessary. I bet some of you already seen this, because this is my report. Instead to write a paper or doing something, I made a video so my report could go everywhere. So this is when I got my jackets. I hug everyone and kiss everyone. I was so happy. That's the restricted area. We got those badges, and I stole my budget. And then this is the training for the airplane. So it takes a long time for us to actually learn how the procedures inside the airplane. So that's basic. Don't touch anything, because there we are as educators, not as scientists or engineers. So now everything approved, it's a go. And then we do the ingress. So during the ingress is like me coming into the airplane. I'm so excited and take pictures and going to places where I'm not supposed to. So now those guys here are mechanics. So they are safety officers. Do not call them flight attendants. Those are the pilots. So buckle up, it's time to go. So you don't even feel the telescope opening, but you can see the graphics showing the telescope is opening. And then there's getting data. So now this is a few time lapses that I did with my own camera in the airplane. And when you see the telescope moving, it's not actually the telescope that's moving. It's the airplane that's moving around the telescope. The telescope is steady without moving. And as the airplane flies, the telescope is independent. So this is what they call the blue ducklings, the ambassadors, because we wear the blue jackets and we walk in line in areas. So, and then those are our seats, and we are seeing the data and trying to understand and conversing about science. All then got hooked up and went to sleep. I did not. So this is SOFIA, the one I have that flown on SOFIA. So I travel around with my little SOFIA. So this is Donna Bachman. He's our principal instructor, the one who actually explained what we are doing. And then we got to interview the pilots, interview the scientists, interview the telescope operators. This was kind of exciting. So it was very loud inside the airplane, so a lot of noise. So we need to use the headphones, and we talked through the headphones. And how lucky it is that I got to see the aurora from the stratosphere. I dreamed to see the aurora, but I got to see from the stratosphere. So then at the end, I was so tired. So I was very tired, and they told me, would you like to land with us? So they accept me to land. So I was very happy. I realized two dreams at once. There's dinner with the bosses and SOFIA and me. And by the way, the red one is the picture that was taken with SOFIA. So you can see the cloud of dust around, and that cloud of dust actually makes new stars that you can see the data on Hubble. And then you can see the ionized gas and warm dust, depending which kind of instrument you're using. So this one and this one is SOFIA. This one is Hubble. And I'm not sure which telescope took this picture here, because this is ionized gas. So it could be Hubble too. So then the next part is, oops. Now, because I was dealing with the crowd, I kept doing like those questions because, you know, excited the crowd, it makes it exciting. So who was the lucky one who went to the edge of space? And then this is my credentials. Me, Héllen Távora. And then this me near to Sophia. And then this is who I am. I'm Airborne Astronomy Ambassador. I am a science communicator for Broward Astronomy, and I am the didactical coordinator for the Fox Observatory. So those basic using that for, you know, to see how lucky I am that I got to go and I got to see the aurora. I got to fly to the edge of space. So yes. So let's talk about the lady, Sophia. So it's 2.5 meters or 100 inches telescope. It's a little bit bigger than the Hubble Space Telescope. And it is in the 747 SP. So it means that it's a little bit shorter airplane. So it's a little bit smaller. And then has the same engine, so it can fly for 10 hours. And it takes data when it's in the stratosphere. So it's above 99.9% of the vapor of water, because vapor of water blocks the infrared light. So you won't be able to see anything in the infrared unless if you go to space or you go above the clouds. You can see some infrared from mountaintop telescopes, but the data is not that good depending on which wavelength you're doing it. So Sophia is special because it can go anywhere. It can update the instruments when it lands. And also the wavelength that Sophia can do, depending on which camera you put on Sophia, you can have a wider wavelength. And then, you know, it's easier because when you put a telescope in space, that telescope cannot ever be fixed. Maybe it's the Hubble, but if you go to the newer telescopes, they're going to be in Lagrange points. So they're too far away for you to send missions to update them or fix them. In the case of Sophia, all you have to do is land. And the other advantage from mountaintop telescopes is that you have close to the wavelengths that you can see in space. So it's like a really advantageous to have an airplane in the airplane with a telescope. And the other thing that Sophia does that's special is it follows shadows. So when you have transit of planets, asteroids in front of stars that are far away, you can actually follow that shadow and see the detail in the chemistry of the atmosphere of those objects. So quite a few advantages. So during the flight, the telescope's door is open and exposed to the atmosphere. So it only when it gets to the stratosphere is when it takes pictures. So the garage, the ginormous garage door opens and exposes the telescope. So as you saw in one of my videos and the next one you're gonna see, because it has a gyroscopes, it keeps position that's quite precise. And other that, the vibration of the airplane is isolated by the gimbal, by the whole system. So this is completely isolated. So the telescope remains stable during the flight and fixed in the target. So that is no problem for, you know, to follow objects. So I'm gonna play this little video here. And as you can see from the frame of reference of the telescope barely moves. And what is actually moving is the airplane. So it's like a trick of camera. So I'm going to put the mouse on the top. So it barely moves. And you can see the airplane's moving and the telescope stays stuck, you know, pointing to specific stars. So it's really cool to see that. But when you're in the point of view of the airplane, is the telescope that is moving, not the airplane, because you're in there. But the actual is that the telescope doesn't move. What it moves is the airplane around it, isolated from the telescope. So this is the basic layout of the airplane. So here's where we take nap or eat. So that's the area that we do. Over here is the famous questions the Boy Scouts ask. Those are the bathrooms. So we go normally to the bathroom. And then those are the pilots. So that's few areas here that you have for resting. There's more here that pilots can rest, because you need pilot, co-pilot, and you have a flight engineer, because this is an older airplane and there is a lot of technology in this airplane. And then you have the more 3 people that are around the airplane, or taking a nap, because you need a 10-hour shift. You need two crews flying the telescope. Now, then you have this area here is the area where the teachers stay. So that's where you have the consoles for the teachers, where we follow the mission. You can see a few views of the consoles of the people who are doing the science. But those consoles are actually active. So in case of emergency, we need to move ourselves to the front where you have the first class, and then people can use those computers, and they tell us, do not connect your own computer or own phone to the airplane, because they're afraid to have any kind of bugs that can damage the data. Then this console here, this area here, is where Captain Kirk and Spock stay here. So this is where you have the first officers, the people who command the mission, and they keep the radio in all channels all at the same time. They pay attention to every system, and then they command the pilots or the telescope operators to do changes in the telescope. This area here is for the instrument operator. So you change what type of camera. So here's the bulkhead, and this is the telescope. From the borehole, you can put different kinds of camera. So this is controlled by these people here in this area. And the telescope is controlled by people sitting in this area here. So this is the telescope control, and this is instrument control, and they are basically independent. And when SOFIA is doing the mission and it's activated and shows in the target and calculated everything, what actually flies the airplane is the telescope. The telescope is flying the airplane, and the pilots are only monitoring, all the systems, seeing everything is working well, just to avoid problems. So what you saw in the graphic, you're seeing again. So those are the telescope operators. Those guys here are the instrument operator. This is one of the cameras, one of the instruments. You have this table here is for the professors who are asking the data, or people who are invited to come here, so guest observers, or some people from the crew. It depends, depending how many people are doing the gathering data. Those are the mission directors. So the captain and the first officer are right here. And then you don't see, so it's the area where the teachers are is the next console that's not in this picture. And this guy here is a pilot. So this is the resting pilot who are not flying the airplane. So that's basic how it is on board SOFIA. So it flies. And then if you can see the straight lines when getting data to a specific object. So it's moving this way is because it's taking picture to that area over there. And then when, every straight line, it's like it's taking picture of the sky in the opposite direction. That's how the airplane is flying. Now, when the missions start to have very long duration, you can actually see the correction for the rotation of the Earth. So it's not quite a straight line, there's a little bit of a curve. As Earth moves, the targets change a little bit. So you see, the lines are being, a little bit curved to have, some kind of data. Look, this gathering of data here was very short, but some of the data. And then you have some long duration data that was taken, and then this time to go home. So it's basic 8 hours of data, 1 hour to go, an hour to come back. It's 10 hours flights. It starts gathering data from 38,000 to 45,000. It goes up as the airplane gets lighter and lighter, burning the combustible. And and that's the rest of the time to have to go. It's a basic 1 hour to go, 1 hour to come back, depending how far it goes to. And it flies 0.7 Mach. So it's almost to the speed of sound. So it flies very fast for that big of an airplane. So it's very impressive. So then, who wants to see invisible light? That's the time that people, me. And then I'm like, are you crazy? ¿Están locos? No puede ver. It's invisible. But who wants to see invisible? I ask again, and people go and fall for it. They're like, yeah, me. I'm like, ¿están locos? No puede ver. And then I show them you can use an instrument that color codes the light and makes it visible. And one simple example I gave as a homework, that's the homework. Get your phone, get the remote control and try to see the light. So you're actually making something that is invisible, like the infrared light coming from a remote control. And then when you point to a phone that doesn't have infrared filter, you can actually see the light infrared. Infrared is not purple. It's just colored as purple because the color coding of that specific phone. So it depends on the phone, it depends the color coding, it depends the programming. So you can color this in any color, depending how you choose the colors. So that's basic an example, using an instrument to make something that is invisible to something that is visible. So that's how SOFIA works. SOFIA sees an invisible light. So then the wonder of science makes the invisible beauty, like the example of the Orion Nebula. As you can see, this is what you can see in a simple pair of binoculars or even naked eye if you go to a very dark place. So you can see that with your own eyes. But then if you make it visible using an instrument like SOFIA or like a camera, you can see that much of the data. So as you can see, those areas here a little bit hotter than those areas there. So you actually can see inside the clouds so much more stellar formation. So this is a stellar nursery. You can only see a tiny little bit invisible light, but look how much more stellar formation you see in this whole area. You see a huge area in here of stellar formation. Those stars here, they're very hot, actually blowing like a cave inside of this whole area. So you can see like a circular area of the pressure, light pressure that's moving those clouds around. So you can see that it's way much more data that is invisible to us. And then stuff that you can see here. Oh, this is just the sky. As you can see, you see no stars here. This is pure clouds of gas that will form even more stars. So it's really incredible when you use, doesn't matter if it's infrared, any kind of instrument that allows you to see something that your senses, like your eyes or your ears or your touch, to actually be visible to you, for you to notice that. So you use instruments to make sense of things, saying things that our senses don't make sense naturally. So other examples of what infrared can do for you. You can see the features of Jupiter. This SOFIA took it when it was still a proof of concept. I think this was cycle 0 or cycle 1. And then you can actually take a look here. This area here where you see the dark clouds, this area is hotter. So you can see the temperatures. You can see the upwellings, and then the areas that you see in different color codes are a little bit cooler. So you can see the difference in temperatures that's a little bit cooler. So you know that area here is basic clouds of ice or ammonia. And those darker areas would be the long chain hydrocarbons that you find on Jupiter atmosphere. So the other thing that I want you to notice is that you can see here the whole full electromagnetic spectrum. And all we can see, it's just a tiny little band in here. So it's basic, we as species, most of the light that comes from the stars or even comes around us is invisible to us. We are basically a blind species because we can only see a tiny little bit. We can only make natural sense of only a tiny little bit of the electromagnetic spectrum. There are animals that can see in ultraviolet, and there are animals that can see in infrared. So depending on what species, they can see a little bit more or a little bit less in each direction of the spectrum. But we as animals, we are blind to most of the light that we see in the universe. Now, the other cool stuff that we can see is like literally cool or code is the newly formed stars. They're not, burning hydrogen yet. So they are just collapsing and start to forming planets. That's the phase that they form planets. So this is interesting that you can see that through the clouds. You can see that the stellar formation and planetary formation. And this will be also some of the wavelengths that the James Webb Space Telescope is going to do too. And then there's stuff that Hubble can see a little bit in infrared. So in that case, that picture here, it's from the Hubble Space Telescope. It can see all the stars around the area of our own black hole, the Sagittarius A black hole. So that's our home, our own black hole. And then you can see this area has kind of a circular area of stars, but that's all what Hubble can see in most of the telescopes, because SOFIA can change cameras and can see different wavelengths in infrared. We can actually map out different temperature gases flowing into the black hole and around the black hole. So this area here actually is a stellar formation area. So you have a center cluster of stars near to the black hole. And SOFIA actually took long-term pictures and, repeated that pictures in many cycles and added with other infrared instruments. You can actually see a movie of those stars moving around about 20 years. They actually move very fast and whip close to the black hole and move farther away. So this is a really cool area that SOFIA can do specific because it's special wavelengths that SOFIA can see. So it's really cool. That makes the invisible visible. And then the special area that's a basic interest that not just in SOFIA, but also in the James Webb Space Telescope is that when you look at infrared wavelengths, you can do chemistry, astrochemistry, and maybe astrobiology. So we are looking for molecules that give rise to life. And in the case of SOFIA and in the case of James Webb telescopes, we are also looking for gases like oxygen, or we are looking for parts of the gas of methane and ammonia, and we can see processes of those gases. They're very unstable. They don't last long unless they have some kind of process to keep producing them. So if you find oxygen in the atmosphere, it means that something's producing it. And because it's very reactive gas, if it accumulates to atmosphere of a planet, most likely could be a signal of life. So for now, we are only actually doing astrochemistry. The astrobiology is just a hypothesis, but we use the knowledge that we have on planet Earth, that if we find the same chemistry that we find on planet Earth, that we find in our own solar system, everywhere else in the universe, most likely some processes that give rise to life can give rise to life somewhere else. So that's the hypothesis of panspermia. So that's what we are waiting to see, especially nearby, like Mars. Maybe some probes to see if we have some kind of bacteria in the clouds of Venus, but it's unlikely so far for the latest papers being produced. But that is an instrument that you can use to study organic molecules. So this was basic, the presentation that I gave. And then this is a video produced by NASA, so it's way much more well produced than my own video. So it's a very nice video that I show during the presentation. So this is, we are arriving on a flight and doing like pictures and showing off. So those are safety officers. That in the middle is one of the commanders of the flight. So it's a joint program. So it's NASA and the space agents from Germany. So you see, you can actually see in that time lapse that the telescope feels like it's moving, but it's not the telescope, it's the airplane. And here's me setting up my own time lapse. This kid here, who looks like 14 years old, he's the one who are writing doctorate degree papers about the ring, the circumstellar ring around the black hole. So we got to see the aurora. How lucky I was. That was extremely lucky. So then that's the end slide for the presentation. After the video, I tell them that if you want to follow and know some, little detail, you can follow on Twitter, you can follow on NASA.gov, and, do you have that? And then if you want to submit papers or proposals, you need to go through the USRA EDU. That's where they, from your institution, you can apply to do, that is a long process for you to get in line to use SOFIA, but it's possible. But you need to go through your university or through your research institution, through their own, to actually apply for papers for that. And also I mentioned to them that there is a lot of data already in open for use after a year of the research. So there is a lot of raw data that they can use and publish their own paper and get to scoop the scientists who actually request the data. Now, then this is the photo album of Barranquilla for me doing that. So right in the, we arrive at night. So right in the morning, we went to the Barranquilla, planetarium. There we had a class for teachers. So they asked us to give a extension class talking about STEM professions and give some ideas. So we have a scientist from Spain. So he has a particle physicist, and there's me here. First explaining how to use the stuff from NASA Night Sky Network and ESA, all the free stuff that I normally tell teachers to do it. You don't need instrumentation, you don't need anything that it's expensive. There is a lot of resources, so I place on the screen for them to actually see and copy the, so I mentioned NASA Night Sky Network, and I mentioned some of the areas that you can go on ESA, and the universe in a box that you can receive those materials. So there's quite a few. So I actually get to sign the certificate for the teachers as an extension course. So I'm the one of that signed the paper. And I actually, during my presentation, I actually pointed them out that my wings had a book. So it means that I'm also a teacher just like them. And I applied to do some kind of missions, and I told them, look for missions that your country is doing, or the Europeans can do it. Try to apply for those things, because there is a lot of opportunity for teachers to actually go to the missions, because people on the mission, they want to tell, here we exist, please keep our funding. So come teachers, see what we do to teach the next generation. So it's a synergic relationship where people know you exist, you get the funding because you give chance for teachers to participate to your mission, and then you get to educate the next generation who is going to be the people who are going to need the funding to go and so on. So that's very important, because people like me are talking about SOFIA, SOFIA's access to still getting their funding, and people are in the area of education, and you actually get to raise the next generation that's going to be the next one doing the science. So it's really cool to do that, to be part of it. And of course, I brought my FLIR camera, and I took pictures of hands on the floor, and I make them sit on the floor, and they didn't know what I was doing. And of course, the famous butt prints. So that's could not escape, the event. And then this is the crew, like Monroe says, those are STEM troopers. So this is some of them are docents on the Barranquilla planetarium, and some are ex-docents who are, doing the events. So this is the people from the Barranquilla, Barranquilla planetarium. And it's really good. They have a small dome, but it's very nice. I love it there. And then, of course, those are the pictures with the teachers. First, we took a serious picture, but boring. I like that kind of picture. So, we're becoming airplanes and flying. And yeah, so I like the silly pictures. So this is what we did in this, the Barranquilla planetarium. And then it's the next, at night, same day, but at night, we got to present on the big square that they have there near to the beach. So that they have like a amphitheater with people watching, shows and stuff. So they did the whole scientific presentation on that amphitheater. So there was Natalia Hernandez. So she is a mathematician, and she was talking about, how you do science, how you go and you have problems and you get bumped out of some of the studies that you go, and then you keep trying and you change your ideas and you do something different, but you keep going in science. So she was talking about the route of science. And then there was me. That was Lee first. Lee is an ex-trainee at Fox. He was the one that was trained by me, and he did his first video when he was 14 years old of me right after I finished my SOFIA mission. And now he's actually doing his own mission. So he has the airplane that Monroe showed the patches, and he's planning to do a flight through the Latin American, like isolated cities where the teachers have no resources. So he's actually bringing boxes of material, didactical material, to actually bring that. But he actually was the one who did astronaut training in Russia. He's fluent in Russian, and he actually did astronaut training in Star Series. So it was really cool. He showed, how it was, what happened there. And he was so nervous that his pressure got too high, and he was rejected. And then there was Javier Santaolalla, and he's a particle physicist, and he works on CERN, and he explained, you know, he actually did a really cool presentation that he used like big fruits, and he used rice to explain how you find particles, so like colliding the particles to understand what they are. So that was a really cool, simple explanation. And he was talking about his passion about, you know, nuclear particle physics. So it was really cool that a whole city got together to actually watch something that is no singers, no dancers, is actually science people talking and showing boring pictures. So it was really cool presentation. And then we have other presenters, local presenters, and those guys are comedians who have different education in the area of biology. And so they were going to bars and they geek out about their science and show pictures, but they are you know, they are stand-up humorists. And so they use science to make it, you know, fun. And I love their presentation. That was genius. It really cool. And then here's some pictures of the crowd. So this is Lee during his presentation using his jacket. And then this is his translator. So he doesn't speak Spanish. And I thought I spoke Spanish, but when I listened to my recording speaking Spanish, I was like, God, this is really bad Spanish. But they say, no, you spoke good. It's good. I'm like, okay, if you're telling me it's good enough. So that's the crowd when we were watching, you know, the presentations. And this is me, you know, not making funny faces. So that's a miracle. And that's how big is the crowd. So it was really fun. And then the next day, we went to stay the night on the resort in another municipality that it was in a mountain. So this is like they call it glamping. So it was fancy tents with nice mattresses, and it was chef for us to cook. They made special for me because I'm vegan. So they make for me and from another person, like, you know, a vegan meal. And for the other one was just vegetarian meal. So we had a professional chef cooking our food. So it was very nice. And then we did another presentation. So I use, you know, I did the pocket solar system to show them that they don't need to use special paper or anything. All they need is the extension of their arms. So with the extension of somebody's arms, I gave the explanation of the distances of the planets, and also with the extension arm, I gave the timeline of planet Earth. And there was a lot of teachers, by the way, the lady who was standing nearby me that I'm doing the timeline. She is a teacher, so I chose her to be my test subject, because she was learning how to pass along the knowledge. So my whole idea is to get there and say, you don't need expensive material. You don't need an infrared camera. Of course, it's fun to have the gadgets, but that is not necessary. Depending where you are, you can improvise with your arms, with simple piece of paper, or going to a website and printing out the material and giving to people and showing them where to get. Everybody has a phone nowadays, so you can go into the web page and actually look those things. So you don't need expensive material to be a science communicator. All the stuff is there. So all I did is show a little bit of what I knew here, so they can not just wrap your juice, but do innovation, and then and get the next generation of people doing science, doing cool stuff. I already, without me being a science communicator at Fox Observatory, I wouldn't have sparked so many kids to go into science. And one of those kids who got to do science, to go into science, to do those amazing things, it was the one who actually invited me to to an event like this. So it's like synergic because you get someone teaching someone, and that someone gets someone to teach the next generation. So it's really cool to already be seeing the results of my work. It is like beyond cool. And that's the end of the show. You have any questions? If you want to see more silly pictures, you have to go to my Facebook page because there are silly pictures. Those are the nice ones because I'm going to send that to NASA for SOFIA. So I didn't put the silly pictures, but there is lots of silly pictures.
So for those people that might not realize it, one aspect of her association with SOFIA is continuing education. So she has to spread the word of SOFIA, show what she did on SOFIA, tell other people about the importance of infrared astronomy and of SOFIA itself. And when we were doing the James Webb Space Telescope presentation, it turned out that Will, our subject matter expert, actually used some of the data from SOFIA, and we found out that even though SOFIA sees in infrared, the Hubble Space Telescope sees in infrared, and the James Webb Space Telescope sees in infrared, SOFIA actually sees deeper into infrared than does Hubble, than does the James Webb Space Telescope, because SOFIA has instruments that can be upgraded very quickly over time. Quickly is a relative term. Instead of it taking 20 years, it might only take 5 years. Yeah, but it can swap out instruments from one mission to another, and it also has the ability to refrigerate its instruments. So it actually has a 2-stage liquid nitrogen, liquid helium chiller to keep its instruments cold. And it can actually keep its instruments colder than even the Webb telescope can. And the Webb telescope's in space, but it doesn't use helium to cool the instruments.
Yeah, and that part of the SOFIA that takes longer to approve because you need to approve the instruments as a scientific manner that they need to be. But the other thing that you need to approve is FAA because you have an airplane and you have people inside the airplane. Even though it's just 20 to 24 people inside the airplane. So you need to follow rules of aviation and rules of science. So it takes a long time to develop an instrument because it needs to be science worthy and needs to be flight worthy. So it gets complicated. So they were actually in ideas when I was doing my mission. I don't know. I don't think they actually completed that because I think they lost the extra funding. But they had an idea that they would do kind of a box that will be fitted out your instruments. So it was already FAA approved box and you need to fit your instrument inside. And that will be, easier because it would take instead 5 to 4 years to develop a new instrument for SOFIA would take just 2 years or even less because the outside is flight worthy. Now you just need to find a way to make your science worthy instrument, but that never happened. And they actually even have the name for it. It would be an acronym for snakes because they wanted snakes on a plane. They are very funny.
Now, if you remember me talking about CubeSats, there's a standard for what size you have to make it, what its electrical requirements are, what all the data and electrical connectors are. And that's what they were trying to standardize is the internal and connections and physical of any instrument you wanted to bring on board SOFIA so that it didn't have to be reevaluated every time you had a new instrument. If you ever looked at all the instruments that run through SOFIA, it has interesting names like Fifi and Forecast and Hoxie, and they have fun with the acronyms.
Yes, there is a wharf that was used in another airplane that flown on SOFIA a few times. That's like a bunch of instrument. Axis, that's the Axis instrument. That's a few that have like funny acronyms. So you guys open for questions. Do you have any questions? What we did there, or
Well done. Well done.
It was so much fun, and I got to actually stretch a little bit my Spanish because it was about 2 years that I didn't spoke Spanish to do a presentation, because at Fox I did presentations in Spanish all the time, but I got to stretch a little bit my Spanish, so it was a good exercise. And when I listened to myself speaking, it was like, oh my goodness, I'm speaking like super like gringo, so bad. It's like in my head, I spoke a little bit better Spanish, but listen to the recording, no, it's so bad. But everybody was saying they understood me, so I was happy. The other thing is that I never did a huge presentation in SOFIA in Spanish, and there was lots of words that I knew how to write, I knew how to translate, but the problem, I never heard them pronounced. So I didn't know where is the stress of the syllables. So yeah, it was a little bit of a learning curve. And I probably forgot all they taught me already. But it was awesome. It was awesome. But I listened to myself speaking, and it was like gringo.
You can blame me. I'm the closest gringo you've got that will butcher your language.
Yes. Very impressive people there, especially the physicist. He's like 40 something. It's very young, and he used grapefruits to actually explain the collision of heavy elements in the collider. And then he talked about the energy of colliding, so you send packets, so he got like 2 packets of rice, and people throw to collide, so they actually collided. And then he got 1 grain in each one of them and see how easy is it to collide that. So he was explaining that what their testing is the probability of collisions and what kind of material come out of collisions. So I like the way he explained, because he did the explanation like I do. I use stuff that I find in my kitchen, stuff that, paper, improvised to explain that. So it's really awesome to get someone explaining something that's so complex in a very simple manner that anyone can understand. So I really like the presentation. It was a very good city. It was very similar to Manaus. Fancy new malls, the place where you have the river, you have a place where you have shows, you have public squares, people. And the other thing is that when you hear about Colombia on the news, you see, oh, it's dangerous, it's Medellin, it's like, it's like, no, it is awesome. I felt safer in Barranquilla than sometimes in some places in Miami. It was awesome. It was a little bit cooler than Manaus, so the temperature, it wins. The culture, the food, and the way the people are very friendly. This was like Manaus, so I love it. I felt like whatever I looked like, even the older buildings and the places where I went, it's almost the architecture. Architecture is very similar with the people who doesn't use air conditioner. So you have like cooling areas in the buildings where it keeps cooler because it's an older building. I felt like I was in Manaus. Unfortunately, they let me, they brought us to the fancy places, beautiful place where they didn't have rice and beans, because that's what I want to eat. So as soon as I arrived home, I made a rice and beans and ate it. So you guys have any questions about anything about,
No, it was really fun. It's great. Fun.
Yes.
Why is
love
the
the
dark
teachers.
band? Why is the dark band on Jupiter warmer?
Because it comes lower. It's lower. It's lower, and also it's kind of brownish color because it has methane, methane, and some other hydrocarbons, and is a little bit lower in the crowd. So whatever you see on Jupiter, you have the darker areas, they're always hotter and they are always lower. And whatever you see in Jupiter that's wider is ice clouds of ammonia. So it's, you basically see clouds of ammonia, the higher. And so higher, you have the clouds of ammonia that it's icy. And that's how you know the different temperatures and altitudes as you see the pictures. And if you take a look in some pictures of Juno that Monroe mentioned, you can actually see that's very close by. You see that the darker areas are lower and the higher areas are clear. So you can actually see, almost look like mountains. So you see the ice clouds look like mountains, and the darker areas look like lakes. It's all gassy. And I didn't know that before I went to the year that I had to study physics for SOFIA. I actually, had to study that.
A lot, yes, I remember. Yeah.
Yeah, it was, I was sleeping
A
like
lot of
4
work.
hours
Oh,
a day
yes.
because
I
I had to
remember
follow the classes, do the homework and work at the same
And
time.
all
So
the
I was a
math.
zombie.
And the math you had to do, all the
Oh
math.
yeah, the math was
Oh,
painful.
that
The
was
math
gruesome.
painful. Yes, because even though I understand a lot of the physics, I'm very weak in math and I need all the help. So I asked help to everyone because I didn't want to lose, get, bombed there, because if I don't go, my colleague didn't go, so Nathan wouldn't go. So like, you have to help me.
Okay, we are not going to have any more sessions the rest of the year. So December 25th and January 1st, there won't be a session. So enjoy your time off. We'll start back in the first of the year on the 8th. So any comments or questions before I stop recording?
Creak, 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 creak.
Okay.